So 5.7, we'll look at graphs and we will see and identify what our increasing and decreasing intervals are. So where a graph is going up from left to right and where a graph is going down from left to right, which is really simple. And then we will switch to, I give you a function and you graph it, you find the zeros, the local max and min, like you've already know how to do, and then we use that to come up with our intervals. So first section is I give you the graph, we use the points from the graph. Second section is I give you the function, you graph, and you come up with the points, which is what you're going to see on your test. It's where I give you the function, you have to come up with everything else, okay? And then the end is where we find out if functions are even and odd, okay? So you will not have a quiz over this one, but it will be on your test, okay? So a function is increasing when the graph goes up from left to right, okay? And the graph is, or a function is decreasing when the graph goes down from left to right, okay? Very simple, self-explanatory of what you think would be increasing and decreasing, okay? So for every single problem, I color coordinate. It helps you visualize. So for increasing, it will be pink. For decreasing, it will be blue for me. You pick whatever you want to do. If you don't have colored highlighters or pens, just really focus on what I say, okay? It's easy to tell from the graph, but the only part that people mess up on, which is a very, very, very common mistake on this lesson, is when we do our intervals, your interval is for your x values, which I'm about to write that down, but people give me their y values instead of the x values. That is where people mess up on this lesson, okay? So what we're going to do is we're going to be doing intervals. So we're going to use parentheses, not brackets, for our intervals. I know that we use brackets when we do domain and range, but we're not going to do that. We're just going to do parentheses, okay? And you are only doing x values. So it's confusing to some because you're looking at where the graph goes up, but you're telling me the x values for which your graph goes up, okay? So from this graph, okay, we're still going to identify our zeros and our local max and min, just like what we did with 5.6, okay? So we're going to estimate this graph. So our zeros, remember, are your x-intercepts. Okay, so I have a 0 right here, which we can estimate to be negative 3.50. I have my 0 at my origin, 0, 0. And I have a 0 right there, which we can estimate to be 3.50. Okay, you should be able to identify that. Those are your x-intercepts. Now, your local max and min. Okay, look at that graph. Where do you see a local max? Negative 216. So I would say that's a local max. Negative 216. And then a local min, where would you say that is? To negative 16. Okay, that you should all be familiar with because y'all just took a quiz, 5.6. Okay, that's what we covered. Now we're going to look at where does my graph increase. So where are my y values going up? Okay, so if I start at the beginning of my graph and I go from left to right, what's happening for this first section? You're increasing until you hit your maximum, and then I stop increasing, okay? So what I do is I trace that back down to my x-axis, and I'm going to highlight everything on my x-axis up into that point, okay? So for my graph, it's going up until it hits a max. The interval on which it's increasing, so I'm going to put an I for increasing, you're looking at your x's. So that would be negative infinity, because it goes on all the way to the left, all the way up to what x value? Negative 2. Okay, so intervals are x values. Then, once I hit that maximum, I come back and I decrease until I hit my minimum. So then that, I'm decreasing from negative 2 to that point at 2. Okay, so for decreasing, I'm decreasing from my x values, negative 2 to positive 2. Y'all see what I'm doing? Okay. Then I turn back around. Once I hit a minimum, I can't go any lower. I only have the option to go up. So I start increasing from there to infinity. Okay, so from that 2 on to infinity, I'm increasing again. So when you have multiple intervals, you're going to separate that kind of like we did with domain with a U. Okay, so I'm going back to increasing from a positive 2 to infinity. Okay, so the reason I'm highlighting my x-axis is so you can just focus on your x-axis. You're going to have to separate y's from your x's. Yes, my y's tell me if it's increasing or decreasing, but I'm only doing it on the intervals for x. Okay? Are we okay with that? All right. So, if I look at my next example, okay, we're going to identify our x-intercepts, which are our zeros, local max and mins, and then we're going to do our intervals. Okay? Notice that your values for your intervals were the x values, not the y values, from your max and min. Because that's what a max and min is. That's my higher point, and that's my lower point. I can't increase any more than my maximum point, right? And then I have nowhere to go but down. Then I can't decrease any lower than my minimum point. So when you do your intervals, you can double check, make sure you're using the x values of your max and mins, not your y values, okay? So, we're going to estimate because we don't know our exact function, okay? If I'm looking at zeros, okay, I have an x-intercept right here. It's not quite at negative 2, but we're going to estimate it to be negative 2, 0. And then I have another x-intercept. It's not quite halfway, but we're going to estimate it to be 0.50. And then my last one, what would you say that is? 1.50. Very good. And then we're going to look at our local max and local min. So this point right here, would that be a min or a max? Is that a low point or a high point? It's a low, so it'd be a minimum. So that's at negative 1, negative 3. So that would be a minimum. And then my maximum would be where? 1, 1. Okay, so then we're going to look at what's happening, and we're going to come up with our increasing and decreasing intervals. Okay, so when I start on my left, I'm going down. So I decrease until I hit that minimum. Okay, so I'm going on my x-axis. What would that interval be for decreasing? To my minimum's right here. Negative 1. Very good. And then I turn around and I increase till I hit my maximum. So I have a short interval for increasing, but what would that interval be? On my x-axis. Negative 1 to positive 1. Then I turn back around and I decrease. So from that 1 till infinity, I'm decreasing again. You understand what I'm doing? Okay. You have questions? I know some of y'all are still writing, so I'm going to give y'all a second to make sure y'all get it down. Good. Okay, this next one. We're going to estimate our zeros. How many zeros do I have? I have 2. Where are they at? Very good. Okay, then we're going to look at local max and mins. Okay, where do I have a minimum? 1, -1. Is there anywhere else? Just estimate that to be like 0.5. It's not, but we're going to estimate that. Okay, so let's say that that minimum would be 4 and 0.5. It's really closer to like 0.75, but we're just going to do 0.5. Okay. Now, where do I have a max? Just estimate that to be 1. So say 3, 1. Okay. So I want you, now that we've picked our points and we've estimated, I want you to tell me, look at your graph and try to do your increasing and decreasing intervals. And then we're going to check it. Okay, even if you're not done, I'm going to go ahead and start going over it. So when you start, you're decreasing until you hit your minimum. So those minimum and maximum points are your cutoffs for your intervals. Yes.
But the arrow goes up.
But if you're reading from left to right, if I'm starting left to right, it's going down. So do everything left to right. Okay. So then I turn around and I increase up until that maximum. So that's my cutoff. And then I decrease till I hit my next minimum. Then I go back and increase. Okay. So my intervals for increasing and decreasing should have those max and min x values. Okay. So I'm decreasing from negative infinity to the x value 1. Then I pick up at 1 and I increase until x equals 3. Then I turn around and I decrease from 3 to 4. Then I turn around at 4 onward, I'm increasing. So if you have trouble when you label your max and mins, go back and like circle the x values. Those are your cutoff points. That separates your intervals. Okay? Are we okay? Okay. So that's when I give you a graph. The majority of the time, I don't even think that's on your worksheet, but you have to see the example before I just have you graph it. Okay? So here, we're going to graph, and then we're going to use our calculator to do our zeros, max, and mins like we did in 5.6, and then we're going to do our intervals, okay? So y'all know how to find your zeros and everything. Yes? Y'all are confident in that? Okay. So go to your graph, and we're going to type x cubed minus 3x squared plus 6. How many zeros do I have? I just have 1. So menu 6, enter. I go to the left of it and scroll over to the right. And we're around to 1 decimal place, which it is 1 decimal place anyways. I know that I have a glare on my screen. So you should be doing this on your own calculator and just verifying the same values. So my 0 is at negative 1.20. Okay. How many local maxes do I have? And how many local mins do I have? Okay, so we're going to find those. Menu 6, 2 gives me my minimum, so I go to my low point, my low curve, go to the left of it, scroll over to the right. That minimum is 2, 2. And then menu 6, maximum is 3. Go to the left of it, and then go to the right, and that's 0, 6. Okay, now my instructions don't tell you to make a table, so you don't have to. If you want it for accuracy, you can. But you can just use these and like make the shape of your graph, because all the points that matter are your max and min that are cutting you off for your intervals, right? Okay, so we're going to plot our negative 1.20, our 0, 6, and our 2, 2. So I know this 6 is a maximum, so I'm going to pass through that 0 and just keep going down. And then I know that 2, 2 is a minimum, so I'm going to hit that and then come back up. Just like what my graph on my calculator shows. Okay. So then, if I'm scaling that graph from left to right, I'm increasing until I hit my maximum. So I'm going to trace that back down to my x-axis. Okay. Then I turn around and I decrease. And I'm going to trace that back to my x-axis. And then I start increasing onward. So Now, I'm not going to count off if you don't highlight, okay? This is just for you to visualize. I've noticed that this helps, okay? If you can just use your pencil and draw it down to your x-axis and circle that value, that would be the same as using colors, okay? So, my increasing interval, if I'm looking at this on my x-axis, what is that? Negative infinity to 0. And then at 0, I start decreasing until what? 2. And then I pick it back up at 2, and I start increasing to positive infinity. That's all there is to it. Okay? Not hard. You have questions? Okay. We're going to do one more, and then we're going to move on. So doc B, and then we're going to type our function in our graph, x to the 4th minus 2x cubed minus 4x squared plus 2x plus 3. How many zeros am I going to have listed? How many times does it touch the x-axis? 3. So mini 6 enter. My first one is at negative 1, 0. I'm going to move everything out of the way. My second one is at 1, 0. And then my third one is at 3, 0. You could have easily looked at that and not needed to do mini 6 enter, but I do it every time just to make sure I'm not off a decimal point. Okay? So then I've got local max and mins. So I've got a minimum right here. I don't need to do menu 6, 2 because I know that that point is what? Negative 1, 0. Then I hit a maximum, so menu 6, 3. At 0.2 and 3.2. Okay. Now, I can clearly tell I'm going to have a minimum down here, right? Okay. I know that you can't see it, but when you go and do your menu 6, 2, and you just go somewhere where it's decreasing over to where it starts increasing, it will zoom it out for you and give you that minimum. Okay? So that would be at 2.3, negative 9.9. Do you all see how I did that when you can't see? Now, if you want to zoom it out on your own, just to make sure you're accurate, you can do menu, and then option 4 is zoom, and you can zoom it in and out. Okay? So, I don't do that because I know it will zoom it out for me, but if that's what makes you feel comfortable, then do that. Okay? So, I'm going to plot my points. So I know I go down until that negative 1, 0, then I bounce back up, and then I come back down, and then I bounce back up. So now, when I start from left to right, I'm going down until I hit that minimum. So that decreasing interval would be what? Very good. And then I turn around and increase until I hit that maximum, which if you can't tell on your graph, go back to what that maximum x value was. So from -1 to 0.2, I'm increasing. Yes? Okay. And then I start decreasing again until I hit that minimum. So from 0.2 to what? What was that minimum x value? 2.3. And then from that 2.3 onward, I start increasing. So see how you're using just those x values? So if you're at your graph and if you are highlighting and you can't remember what that point is, just go back to the x value of that max or min. Okay? Do we feel okay? Okay. Just be careful to do your x's, not your y's. Alright. Now, this even and odd function section will be without the graphing calculator on your test. Just letting you know that. Okay? So, even and odd functions are really not based off of what we've been looking at, even and odd degrees. Okay? This is really, if I were to graph a function and I look at the original function and I take f of negative x, so I make all of those x's negative. Okay? An even function would be, it would be perfectly symmetric along the y-axis. Okay? So what that means is if I take each x value and make them negative, all the y values are the same. Okay? So this f of x equals f of negative x is the statement that makes it even. Okay? For it to be odd, you would have to meet that f of negative x, so I took those x's, I made them negative, and that would be equal to the negative y's. Okay? That just means if I were to graph them, then they would be symmetric along the origin. We are not graphing. Okay? That's just where even and odd comes from. Okay? So what we're doing is we're going to analyze, first we have our f of x, that's given. Okay? Then we're going to find f of negative x. If those two are equal, then it's even. Okay? If they are not, then you find negative f of x. If that negative f of x is equal to the f of negative x, then it's odd. If it's not, then it's neither. Okay? So I write this out to the side because if you're a visual learner, you can see it in order top to bottom. Okay? You're given f of x. The very first thing you find is f of negative x. It either works or it doesn't. If it doesn't, you find your negative f of x, and you compare that to what's directly above it. If that works, it's odd. If not, it's neither. Okay? It's not hard. Okay? But what I do want to tell you is when we do our negative x, okay, if I take negative x and raise it to an even exponent, okay, so think of any negative number raised to an even. So negative 2 squared. Does that give me a positive or negative number? Positive. So any negative raised to an even exponent will be a positive x. If I take a negative and raise it to an odd, so think about negative 2 raised to the third power, that would be negative 8. So that would give me a negative value. Okay? So we're only changing odd exponents. Y'all remember doing this? Did we do something like, I think so. I got y'all and my 3AP mixed up, but that's okay. You're only going to change your odd exponents. Okay, we did this with the Descartes rule of signs, right? When you had to do f of negative x and find your negative possible zeros, and you looked at only your odd exponents and those changed. That's the same thing for f of negative x, okay? So, my first example, f of x equals x cubed minus 7x. That's my function. So I go and I find f of negative x. So my odd exponents change. So x cubed, is that going to change? Yes, it's going to become negative x cubed. Negative 7x, is that going to change or stay the same? Change, it's going to become positive 7x. If you need to go and plug in negative x and figure it out, then do that. But knowing this, I know I taught y'all that for Descartes' rule of signs 5.5. Just use that rule, okay? So then I'm going to compare it to my function. Are they the same? No. So it's not even. So what I need to do now is negative f of x. So what I'm doing is I'm taking a negative and I'm distributing that to my whole function. Okay, so negative f of x, I distribute and it becomes negative x cubed plus 7x. Okay, does that compare to f of negative x? Are they the same? Yes, so that means it's an odd function. That's all there is to it. Okay?
How exactly, like, it just looks all the same.
So f of negative x, you're changing your x values. Okay? I didn't write that out, but because of what I said right here. So f of negative x, I would have taken everywhere there's an x and replacing it with a negative x. Okay? So negative x times negative x would be a positive, times another negative would give me that negative x cubed. And then negative 7 times negative x would give me that positive 7x. So that's the algebra behind this, but I'm just letting y'all use the shortcut.
What I mean is, like, the last one doesn't seem any different from the first one, so how is it, like,
From this one or this one?
both? Like, or, like,
You're looking at your signs, okay? If I have a positive x cubed and a negative 7x, is that the same as a negative x cubed and a positive 7x? No, so it wouldn't be even, okay? So then I'm looking at my f of negative x. I'm done with my original. Once it's not even, I'm done with that, okay? So then I make and distribute the entire, I distribute a negative to the entire function. Because that's what negative f of x tells me. I'm making it all negative. Okay, so that positive turns negative, that negative turns positive. Okay, so if I'm looking at this right here and this right here, if it looks the exact same, it should because it's odd. Okay, does that help? Okay. So then for my next one, I've got f of x equals x to the fourth plus x squared minus 1. That's my original. Okay. So I'm going to find f of negative x. So that would be I'm taking all my x's and replacing them with negative x. Would any of that change? No, because they're all even. So x to the fourth plus x squared minus 1. Is that the same as my original? Yes, so it's an even function. If I were to graph them, they would be symmetric across the y-axis. That's all there is to it. Okay? We good to move on?
Just feels like extra steps. Like, knowing the answer is extra steps. You should just be able to look at the exponent and know. Like,
So it's not technically, the concept is not based off of if the degree is even or odd. The concept is really symmetry. I'm just not making y'all graph it. Okay, so here I've got x squared minus 9x plus 10. If I find f of negative x, is x squared going to change? No. Is negative 9x going to change? Yes. And then I have my plus 10. If I compare that to my original, is it the same? No. So this is what I mean by it's not telling me, you're not telling me if it's an even or odd degree, because if you just look at that, you would think it's even, but it's, the symmetry is not even, because it changed. Okay? So now I find negative f of x. So I've got my negative in parentheses. I copy down my function. So that becomes a negative x squared plus 9x and then negative 10. Okay. So I'm going to compare that to my f of negative x. Are those the same? No. Neither one is equal, so it's neither. It's neither even nor odd. So that means if I were to graph them, there's no symmetry there. Okay? So this last one. F of x equals x to the fourth minus 5x cubed. Okay? F of negative x, would x to the fourth change? No. Would negative 5x cubed change? Yes. Okay. If I compare that to my original, is that the same? No, so it's not even. So now I find negative f of x. So negative parentheses x to the fourth minus 5x cubed. So negative f of x becomes negative x to the fourth plus 5x cubed. If I compare that to my f of negative x, are those the same? No, so it would be neither even or odd. Okay? We good with that? Questions? Okay, so for your worksheet, y'all have about 25 minutes. Get what you need as far as your zeros, your max and mins from your calculator. Don't sit there and graph everything. Just get your zeros, max, and mins so you can get everything you need from the calculator before the bell rings and you go home and you don't have one. Okay?